Hello, everyone. Welcome to my channel where we talk about everything cybersecurity, business intelligence, and cloud computing. In this video, we're going to talk about machine learning model. This is a follow-up video from the first one that I spoke about supervised learning models, and I give a code along and a detailed description on all the nine models that you see here. So I spoke about linear regression, logistics, support vector, decision trees, random forest, KNNs, GBMs, neural networks, and polynomial regression. But in this video, we're not going to do that. We are going to talk about deep learning models. And in specific reference, we are going to talk about CNN, RNN, and LSTMs, convolutional neural network, recurrent neural network, and long short-term memory models. All right. But all these are under deep learning. So before we get started into these models, let's take a step back and talk about what is deep learning. Now, deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. Deep learning is a type of machine learning that is inspired by how the human brain works. So it allows the computers to learn and make decisions without us humans explicitly programming the computer to do so. So basically, all deep learning models, they use neural networks. Actually, it's a series of connected nodes or neurons to process and analyze data. Uh, I would say think of machine or deep learning as teaching a computer to recognize patterns by feeding it with a lot of examples. For example, showing it many pictures of cats and dogs so that it can tell the difference. So actually, I have a project here or where um, I have the computer predicts the image, like what is the image, what is the image in this image. Then it will tell you it's a truck, the deer, is a sheep, whatever it is, right? All right. So you feed the computer with images, then it learns patterns that it can tell what the animal is. Perfect. So how does deep learning work? It have got many layers. Basically, it have got input layer, and I would say the hidden layers and the output layer. So the input layer is where you feed it with the data, be it a text, be it image, be it sound, anything that you might think of. The hidden layers, that's where it process that data through neurons to extract patterns, features, and anything characteristics from that data. Then output layer, this is what you see right at the end, where it predicts uh, the image that you see right here. Uh, there are multiple deep learning models. We have CNNs, we have RNNs, and LSTM that I'm going to focus on this video. But deep learning is very useful in many industries, be it healthcare, finance, entertainment, transportation. Think of self-driving cars like Tesla. They are basically deep learning. It sees traffic signs, it predicts or it tells that this is a stop sign, this is a left turn, right turn, this speed 50, whatever it is. That's deep learning for you. So why is it called deep? So the term deep refers to those layers, the hidden layers of neurons in this in the network. The more layers that it has, the deeper the network it is. So each and every layer processes the data more, I would say, abstractly. The first layer is just where you input. The second layer, that's where it do some computation, some calculations to identify features, characteristics, any trends, anything that it can associate that particular information with. Then the final layer is the decision-making layer, where it will tell you this is a horse, this is a deer, this is a sheep, this is an automobile. All right. So let's quickly, I will provide the code right here, and I'll explain it in every project here. But let me explain what is a convolutional neural network. Now, you would find that the data set that I'm going to use, you can apply them for use different models to analyze the same data set. But for this project, convolutional neural network, I used images from CIFA dataset, which is just basically about a ton of images that you can use to train your model and predict those models. All right, but what is convolutional neural network? It's just a type of deep learning model that uses data to recognize patterns in images and other data, be it audio, be it video, whatever it is. It is made up of layers too. Layers again, it have got input layer, convolutional layer, the pooling layer, the fully connected layer, and the output layer. So what you're going to see at the end right here is the output layer again. All right. So all CNN models, they are used to recognize objects, classes, categories in images. They classify audio, time series, and signal data. You can use it to identify or manipulate or to on signal data. It also identifies basic features such as color, edges, and textures, and used to also to detect complex patterns and complex objects and scenes. All right. So in this project, what I did is I imported the data set from Keras, TensorFlow Keras, and I used that data to train my model. So right here, I'm loading in the data set. Then I went again to build all these steps. If you look at my initial machine learning video, I explained these steps in detail, and I did a code along where you just follow step by step on how I do this. So this is just this is kind of different from what I did on the other video. So I did build my model here and compare my model, evaluate this the scoring. I want to see if my model is performing good. Then, of course, this is visualizing. And also, I end up feeding the model the new data set. And I can do, okay, I'll leave it at 5. And visualizing it and also evaluating the model and testing on new data set. So my accuracy 0.32 all the way to 0.75, which is 75%. Perfect. So this is also a visualization of my training accuracy on the data. And the less data you have, the accuracy is lower, but the more data you have, the accuracy is getting better. That's all you want. So what that does is I end up visualizing 5 images here. That's why you see 5 right here. But you can visualize and see how the model is operating. And you can see my model is 100% identifying the images as they are. So what I'm going to do is I'm going to save this code, this Jupyter file, and it will be, the link will be on my description to the GitHub repository where you can download it and manipulate it further. All right, so let's talk about recurrent neural networks. Now, recurrent neural networks, basically, they function the same, or the deep learning model, they function the same. They have good layers, right? It is recurrent neural networks are trained on sequential or time series data to create that model. It kind of make predictions or conclusions based on sequential inputs. So on this project, what I end up doing is I used the IMDb datasets. Basically, it's just a move reviews. So it kind of binarize the output. Either this review is positive, this review is negative. That's basically what it's doing here. So what I did is I load my dataset. I use the TensorFlow Keras dataset. So on the step 1, I'm loading the dataset. I'm building my model and I'm compiling and evaluating the model. And so visualizing the results, same structure. Then at the end, I fed it with the new reviews. So I wanted to see if the model is gonna review this, it's gonna read this and say this is positive or negative. Basically, that's what I'm doing. Then basically, I'm reviewing the results. So 0.99 accuracy, and you can visualize, you can see my training accuracy and also the validation accuracy. All right, and those new data, The move was fantastic. It was predicted to be a positive sentiment. Then another one that I did is a waste of time. The model wrongly predicted it as positive, but we know that this review is negative. So what you need to do is to fine tune your model, train it one more time on a larger data set to make sure that your model is predicting accurately. There's a video in my timeline that I also reviewed this data set using a different model, which performed way better than this recurrent neural network on this data set. But check it out and look at it. All right, let's talk about long short-term memory model. It's a type of deep learning or neural network that processes and analyzes sequential data again. It is used to analyze and classify, or to learn to analyze, to classify data um, when you have tasks that involve long-term dependencies. All right. It can be used for speech recognition, language translation, time series, sentiment analysis, like what you did on RNNs. It can also use to analyze audios and videos. So you can begin to see that you can use not almost, but most of the models can be used on the same data set. But it depends on your goal and what you want to achieve. So in this project, what I end up doing is I imported the dataset from TensorFlow Keras and again loaded my dataset, build my model, train the model, evaluate the accuracy of the model, visualize the results, and provide it with new dataset. I'm using the same dataset to review movie reviews. So I got a positive review and a negative review, and of course I tokenized it and visualized my results. Perfect. So what I end up doing is showing the accuracy 0.97. Now in all models, the truth is, the more you provide your model with a large data set, the better the results. I just rerun it. The better your results are. It feeds just like ChatGPT. ChatGPT is performing way, way, way ahead than all the other models because they train it on a larger data sets, larger than the Google one or larger than Microsoft Copilot. So it depends. The more you feed it with data, the more it learns those patterns, the more it give you better results. So again, what I'm going to do is I'm going to provide this data set and in my GitHub repository, and you take this, manipulate the way you want it, and also modify it the way you want it, and also share with others. Thank you for watching, and bye bye.